Hi, already I have two videos on recurrence relation. There I have shown the steps in detail. Now here I will do it little quickly, right? So you also get the idea how we can do it quickly, right? I'll just skip some steps. That's it, right? Not direct answer. Let us take. This is an algorithm or a function. We have to find out how much time it is taking. So we know that this will take Tn time. Now there is a loop. If you observe, this is I starting from 1 and I assign I into 2. So this is multiplied by 2 every time. So by looking at the loop, you should know what is the time taken by this statement. Already we have seen this in examples of time complexities. One video is there, you can watch that one. I have shown how to directly know what is the time taken by this one. So we know that this statement will execute for log n time. Now I will not consider this one and this one. If I consider also, again I have to take the degree of an expression and the degree will be log n only. This will be log n plus 1, this is 1, so 2 log n plus 2. Again I have to write log n only. So let us just concentrate on only this statement. This was the main thing, that is printing. The algorithm is doing nothing, just printing the value. So the job of printing, we are considering that one. It's log n. Then how much this one? As this is Tn, so this is Tn minus 1. Now what is total for this one? So this is Tn is equals to Tn minus 1 plus log n. Tn minus 1 plus log n, that Tn is equals to so and so. This Tn is sum of these two. Now what is the recurrence relation? Tn is equals to 1 if n is 0. This is common, you have seen in previous algorithms also. I will not explain now. Then this is Tn minus 1 plus log n for n greater than 0. Now I will solve this one using tree method. So if I take Tn, what it is doing? It is taking log n time and it is calling itself for Tn minus 1. Then what this will do? This will take log n minus 1 time and call itself for n minus 2. Then this will be log n minus 2 and call itself for n minus 3. Goes on. So at one point it will be what? T2. So and it will look log 2 times and it will call itself for 1, and this will be log 1 and this will call itself for T0. So this will stop at 0 when n becomes 0. Tree will stop there. Now what is the time taken in each step? Log n here, this is log n time in this call, log n minus 1 time in this call, like this. So this total is, I will take few terms only, log n plus log n minus 1 plus goes on to log 2 plus log 1. This is the summation of the time taken in each call. What is this equal to? This is log n into n minus 1 into goes on to 2 into 1. I'll write this in square brackets. So what is this? N into n minus 1 into so on to 2 into 1. So it is just like 1 into 2 into 3 into 2 n. So this is nothing but log n factorial. So here I write log n factorial. Log n factorial. Already we know this. There is no tied bond for this one, but there is an upper bound for log n factorial. For n factorial, upper bound is n power n. So for log n factorial, log of n power n, that will be equal to big O of n log n. So that's it. This is the time we got. So the time taken by this algorithm is n log n. n log n. Right? So this is with the tree method I have shown you. So we got the time complexity as n log n. Now by using induction method I will solve this recurrence relation. I'll remove this and I will solve that one directly. Let us solve this recurrence relation by induction or substitution method. So I'll write this recurrence relation Tn is equals to Tn minus 1 plus log n. Then directly I'll write down this will be what Tn is equals to, in place of this what it will be, Tn minus 2 plus log of n minus 1 plus this log n as it is. This was the first equation. Now if I simplify this one, open the brackets, Tn minus 2 plus log of n minus 1 plus log n. Then this is the second one I got. Then I will substitute this one. So this will be Tn is equals to, in bracket, Tn minus 2 will be Tn minus 3 plus log n minus 2 plus these terms as it is, log n minus 1 plus log n. This is in brackets. I'll open this one. So Tn is Tn minus 3 plus log of n minus 2 log of n minus 1 plus log n. This is the third one. If I continue for k times, then what will happen? See, this was n, then n minus 1, then n minus 2. So it will be go on reducing up to 1. So directly I will write down. So here I continue. So Tn will be equal to Tn minus k plus log 1 plus log 2 plus goes on to log n minus 1 plus log n. Now we know that n minus k is equals to 0, therefore n is equals to k. Now if I substitute there, Tn is equals to, this becomes T0, and all these terms if I add, I am getting same terms. So this is log n factorial. Now I will not show how to get that, already we have seen this in the previous method. This is 1 plus log n factorial. What is the time taken in this one? This is big O of n log n. That's it. We got the same answer. That is big O of n log n. That is log n factorial. Now, if you have already seen first and the second video for recurrence relation with decreasing functions, this is the third video. If you have already seen those two, then you can understand this. Now I am going to show you how we can directly get the answer for a recurrence relation of decreasing functions. See, I'll take the examples of first two videos, then also this one, then let us see. See, there I just write a simple expression. Tn was Tn minus 1 plus 1. And the time taken in this one was, I'll just say order of, not big O, theta, anything, just order of, means just the degree I am writing. This answer was n. And the second video we have seen this Tn minus 1 plus n. So this was n square. And in the third video, this one, in this video, just now we have seen this Tn minus 1 plus log n, and this is n log n. So what do you understand from this one? So when this is t of n minus 1 means n is decreasing every time. So if it is 1 multiplied by n, if it is n multiplied by n, n square, log n multiplied by n log n. So it means we can make out that if a recurrence relation is Tn minus 1 plus n square, then it will be definitely into n, so this is n cube. Yes, this is true. Right? So whatever the term you are having here, just multiply it by n. Because this is going to repeat for n times, so that's why this whole thing into n. If from the first one, I am just making some change. Tn minus 2 plus 1. Instead of n minus 1 plus 1, it is minus 2 plus 1. So the exact answer you may be getting as n by 2. Because it is taking 2 steps every time. Instead of 1 step, 1 value decremented, 2 values decremented. So it will be n by 2. That is again order of n only. Means that even if you have Tn is equals to Tn minus 100 plus n, then what will be the answer? As this is n, just multiplied by n. So it's order of n square. This is n minus, not 1, n minus 1, it's n minus 100, whatever it may be. So it is taking 100 step every time, plus 100. So imagine n value as in 10,000s or millions, a bigger value, very big value of n. For small values, you can say that no, it will not take that much time. Big values of n. So we say that whatever the value of n may be, from some value to infinity will go. So yes, this is true. So whatever is subtracted, you get the same answer. But if you have a recurrence relation like this, 2 into t of n minus 1 plus 1, if there is some coefficient here, then it's not directly 1 into n. So we'll see what will happen in this one, right? See, there were no coefficients here. There were no coefficients. Only these values were changing. 1, n log n, n square, n cube, n log n, anything. So whatever you have here, just multiply it by n, right? But now if there is a coefficient, then what should be the answer? You will see this in next video, next to this one.